Can't get it to line up today. Okay, so like I was saying, brand new stuff, new thing, new section. Probability is the likelihood that something will occur. If you play the lottery, you know you have a really bad probability, bad chance of actually winning the big prize. Definitely a better chance of winning a buck or two to hopefully help you keep coming back and playing, but you have a probability of winning. If you play any card games or anything like that, there's a probability of getting different cards. So the probability is the likelihood that something will occur. An outcome is one possible result from an experiment. A lot of times when you think of outcome, you think of science class. Because in science, you've got an experiment that you did. And then from that experiment, you have an outcome. Something occurred. And you learn something from that result. So the outcome is what actually occurred. One possible result from the experiment. One possible result. The sample space is the set of all possible outcomes. So for example, what they said, if they flip a coin. If you flip a coin, only two things could happen. You could get a heads, you can get a tails. That's the sample space, or the different things that could occur. If you're playing the lottery, the sample space would be absolutely huge because there's lots and lots of different things that could occur. If you're rolling just a normal six-sided dice, the sample space would be 1, 2, 3, 4, 5, 6. That's the only thing that could occur. 1, 2, 3, 4, 5, 6. That's the sample space. Outcome and event kind of go together. The outcome is one thing that occurred. The event is if you keep running the same experiment, different things might come out. So the event is the collection of all the outcomes. So if you keep rolling the dice, if you keep flipping a coin, that's going to be an event. An event may be 10 flips of a coin. An event may be 50 flips of a coin. It's all of them put together. All of them put together. So those 4 vocab terms. Any questions on those 4 vocab? So for example, the probability of tossing a coin and having heads show up can be expressed from a 0 and 1. So they're never going to write out the word probability. They're going to put a P. P stands for probability. In the parentheses, what they want to have occur. So that's the event. That's what they want to have happen. So the top is going to be what we want. The bottom is going to be the total that could occur. So the probability of heads, there's 1 heads on a coin. There's 2 total outcomes. So it'd be 1 over 2 would be the probability of leaving a heads. That's known as the theoretical probability, the mathematical chance that something could occur. So theoretical probability is the mathematical chance that occurs. If you go to the Ohio Lottery website and pull up any of the lottery games, it'll give you the probability that something could occur. It'll give you that probability. Winning a little prize of like $2, you might have a 1 in 10 chance of winning. Winning the big prize is a 1 in like however many million chance of occurring. That's a probability. Any questions on this set? So here's another example. Suppose a card is randomly chosen from a deck of 52 cards. What's the theoretical probability of choosing a king? So if they want a king, they're going to put probability in the parentheses king. Where there's 4 kings in a deck of cards, there's 52 cards. So the probability, the theoretical probability of getting a king would be 4 over 52, which reduces to 1/13. Now that's different than an experimental probability. Experimental probability would be is if I fan out a deck of cards, I say pick a card, pick a card, pick a card, pick a card. And I figure out how long it took before you got a king. That's more of an experimental probability. Theoretical is what should occur. Experimental is what did occur. So there's kind of a difference between those two. Any questions on the deck of cards one? So like this one. When an experiment is performed, the result does not follow expected probability. For example, if you flip a coin 4 times, there should be 2 heads, 2 tails. But a lot of times it won't come out that way. It may be 1 in 3, maybe you got all 4 heads, maybe you got all 4 tails. That's the experimental probability, is what actually did occur as opposed to what you think is going to occur. So if they did flip the coin 4 times and they got 3 tails 3 times, the experimental probability would be 3 over 4. So always look to see on these problems, are they looking for the experimental or are they looking for the theoretical? So 1, 2, and 3. Couple of examples. Suppose this marble is chosen randomly from a bag containing 3 blue, 2 red, 5 green. Now this is asking for the theoretical probability. So they didn't actually do the experiment. They just think this is going to occur. Remember, it's what we want over the total. So what we want is blue. So the probability of blue, well, how many blue was in there? 3. So 3 blue out of how many total marbles? 10. 3 over 10. That's it. Because today we're just looking at simple probability. Now through the week and into next week, they will get a little bit trickier. But these are just simple probabilities. Does 3 over 10 reduce? Nope. Red. What's the probability of red? 210, which does reduce to 1/5. So if you get a fraction that reduces, you really should reduce it. Reduce it if you can. Green. How many green are in the bag?
5.
So 5 out of 10 reduces to 1/2. So that was theoretical probability. Based on what was actually in the bag, this is what we think would occur. If we did it 10 times, we should get blue 3 of them. If we did it 10 times, green should happen 5 of them. As opposed to the next set, are we okay? 1, 2, 3? The next set, we're looking at experimental probability. So the experimental probability is we had this spinner. The spinner had 3 equal sections labeled A, B, C. So we had a spinner, kind of 3 equal sections, A, B, C. Well, the theoretical should just be 1/3 for all of them, because they're all equal size. But as you know, where's the fun in that? Usually doesn't come out that way. So they went ahead and spun the spinner 12 times, and they said this is what we got. So how many times did they actually get the A? 5. So the experimental probability would be 5 over 12. 5/12. B, how many times did they actually get B? 3/12. 3/12 does reduce to 1/4. How many times did they get C? 4/12. 1/3. So C was the only one that came out as expected, where the experimental and the theoretical actually was the same. The other two, one was a little bigger, one was a little smaller, which happens most of the time in experiments. Most of the time, you're not going to get the theoretical probability. Number 7. If the theoretical probability of an event occurring is 5 over 7, 5 sevenths, what's the theoretical probability of the event not occurring? So if something's going to occur 5 out of 7 times, 2 out of 7, because 5 over 7 plus 2 over 7 equals 7 over 7, which equals 1. So if you look at an event, and you look at that event not occurring, it's always going to add up to 1. This is known as complement events. Complement events are events that together are going to add up to 1. The chance that something will happen, the chance that something won't happen. They're going to add up to 1. Complement events. Any questions on those? I'm going to pass out the worksheet. I'm going to do a couple of them with you, and then you'll have probably about 20 minutes to work on it. It looks long, but these actually go really, really quick. These do not take long.
Can I use yours real quick?
It's like I said, we're going to look at a couple of these together. So this first set, we're looking at the experimental probability. So they rolled a dice. They rolled the dice 10 times. And then they listed everything that occurred. And we want to know what's the probability based on what they actually did. So for example, rolling a 6, number 2. How many times did they roll a 6? 2. So it'd be 2 over 10, which reduces to 1/5. So you're going based on what actually happened. So it's really important when you're looking at questions. Did they say experimental probability? Did they say theoretical probability? So make sure you look to see which one it's actually asking for. So 1, 2, 3, and 4, just like that. Now 5 also uses the experimental probability. But I had a lot of people a little bit confused. Let me kind of explain number 5. It says, what's the experimental probability of rolling an odd on a standard number cube? So that's the first question. Is probability of an odd. So figure that out first. Based on the experimental. Based on experimental, what actually occurred. Now, that's out of 10 times. So they're saying if that trend continues to occur, and they were to roll the dice 50 times, how many times are they probably going to get an odd if it was 50 times based on the experimental? Based on the experimental. So you can figure out how many odds occurred out of the 10. Well, then you're going to change it to how many odds occurred out of 50. So basically you're going to end up with equivalent fractions. So 1 through 5. Any questions 1 through 5? Next set. 6 through 11. Theoretical probability. Now, theoretical probability is what we think will occur. Mathematically, what would occur? So, for example, number 6, rolling a 5. Well, how many 5s are on a dice? Just 1. So there's 1 5 on a dice. How many sides are on a dice? 6 if it's a normal dice. So 1 out of 6. So 7, 8, or 9, basically the same thing. 8 is asking for an even number. So how many even numbers would occur out of the 6 dice? 10 is odd. Well, if you figure out even, you should be able to figure out odd. 11 is multiple of 3. If you're looking like 3, 6, 9, 12, 15. If you're looking at multiples of 3. So that's it. Is there going to be any questions on that you're not sure about? Anything I need to explain better? Through 15, we've got ping pong balls, different color. Just make sure when you're figuring out the probability, you realize that it's asking for not the color. So you want everything but the red, everything but the green. So just make sure you get everything but that color, because it's asking for the not red. Not red. So 12 through 15, you're figuring out the ping pong balls, just make sure you got not the red, not the green. Not the daddy, sorry. You guys probably don't even know that show. That was a while ago. Questions on that set?
Is that a reference to dinosaurs?
It is a reference to the dinosaurs.
That's a
It's
good
not
show.
the mama.
It's not the mama, sorry. Girl, I don't know it either.
That's a funny show.
It was a funny show. That was a long time ago though. 16, you're actually doing both. 16, part A says experimental probability. So you're using this information for A. B says theoretical probability. So you're using the picture. So A is the experimental. What happened based on when they actually spun the spinner, or they did the beanbags. B is the theoretical. B is the theoretical. We understand 16? 17 I talked about in the notes. It says, how is the probability of an event and the probability of its complement related mathematically? I talked about that. Now, I need to explain this set. So, listen. So far in everything else, we either flipped one coin, we rolled one dice, we did one spinner, but this one is saying we have 2 cubes. Now, it's a lot easier because we're looking at 2 cubes to make a probability tree. Now, I'm sure you've done a probability tree in the past, probably back in like 7th grade. So the probability tree says, I'm going to do kind of the 6 numbers. So this would be kind of the first dice. So the first dice I can get 1, 2, 3, 4, 5, 6. That's the first dice. The second dice I'm going to put underneath 1, 2, 3, 4, 5, 6. So if I had 2 dice, I could get a 1 and a 1, a 1 and a 2, 1 and a 3, so on and so forth. 1, 2, 3, 4, 5, 6 on all of these. And these are a lot easier to kind of figure out if you do this probability tree. So I have a probability tree. Usually you kind of do them all across the top and bring them down. I didn't really have enough room, so I kind of put them on the side. Now 18 says a sum equal to 2. Well, if you're rolling 2 dice, how many times or how many different ways can you get a 2? Just one, right? Because you have to get a 1 and a 1, right? It's the only way to get a 2. So a 1 and a 1 is the only way I could have gotten that 2 out of 6, 12, 18, 24, 30, 36 ways. So a sum equal to 2 is a 1 out of 36. So that's why getting snake eyes is hard to get snake eyes. Because it's not going to happen very often. As opposed to getting maybe a 7. 7 has the most probability of occurring because there's lots of ways to get a 7. Well, 19 is not equal to 2. Well, if you can figure equal to 2, you should be able to figure out not equal to 2. 20, make sure you realize it says product. What does product mean?
Total
Total after you did what?
multiplication.
Multiplication. So remember, total after you multiply. So you're multiplying the 2 numbers, and you want the 2 numbers multiplied to give you 15. So just make sure you realize that it's multiplied there. 21, you're looking for sum greater than 6. So you're going to figure out how many total times between all of these added together you can get something greater than 6. It doesn't include 6, greater than 6. 22 is another product. So if you multiply, you want less than or equal to 2. There's not too many of them. Less than or equal to 2. And then 23, sum equal to 12. So you want box cards. So you're going based on the 2 dice. Some of them are sum, some of them are product. Does that set make sense? Because I had a lot of people kind of confused on that set, so I'm trying to explain it a little bit better. Just a couple other questions. for an event to have a probability of 1 and kind of explain yes or no, what does that mean? And then 25, it says out of 20 coin flips, your classmate gets heads 14 times. She determines that the experimental probability of heads was 1/2. You kind of want to explain what did they do wrong. Something's wrong in this line of thought. What did they do wrong? So that's 25. Yes, it seems like a lot of questions, but most of them take maybe 5 seconds. Most of them are really quick. So go ahead and work. You've got not quite 20 minutes, about 16 minutes. You should get close to done in the 16. Close to done. So go ahead and work on it. If you need help, feel free to ask.